Hello everyone. In this video, we're going to talk about adding and subtracting square roots with the same radicand. The radicand is the number underneath the square root symbol. Square roots with the same radicand can be added or subtracted by adding or subtracting their coefficients. For example, if we have a times the square root of n plus b times the square root of n, this is equal to a plus b times the square root of n. The same rule applies for subtraction. A times the square root of n minus b times the square root of n equals a minus b times the square root of n. This operation works because the radicands are the same. One important thing to remember is that if no number appears outside the radical, it is understood to be 1. So, for a radical without a coefficient, the coefficient is considered to be 1. For example, the square root of 5 is the same as 1 times the square root of 5. Now, let's go ahead and solve example 10, which asks us to find the value of 7 times the square root of 2 plus 5 times the square root of 2. According to what we just discussed, we can simply add the coefficients, which are 7 and 5, and then multiply by the square root of 2. This gives us 12 times the square root of 2. Sometimes you may encounter situations where the radicands are different in the square roots, such as in example 11. In this problem, we need to simplify the expression 4 times the square root of 50 minus 6 times the square root of 32, where the radicands 50 and 32 are different. When the radicands are different, we need to simplify the radicals first. We apply the principle of simplifying square roots by finding the prime factorization of each number to see if we can take out a perfect square. After simplifying the radicals, we can check if the radicands become the same, which would allow us to combine the terms. Let's start by simplifying the expression 4 times the square root of 50 minus 6 times the square root of 32. First, we find the prime factorization of each radicand. The number 50 can be factored into 2 times 5 times 5. For 32, the prime factorization is 2 times 2 times 2 times 2 times 2. Since 25 is a perfect square, we can rewrite the square root of 50 as the square root of 25 times the square root of 2, which simplifies to 5 times the square root of 2. We know that 32 is equal to 16 times 2, and since 16 is a perfect square, we can simplify the square root of 32 to 4 times the square root of 2. Now let's rewrite the expression using these simplified radicals. 4 times the square root of 50 becomes 4 times 5 times the square root of 2. 6 times the square root of 32 becomes 6 times 4 times the square root of 2. This gives us 4 times 5 times the square root of 2, which is 20 times the square root of 2. 6 times 4 times the square root of 2, which is 24 times the square root of 2. Now we subtract 20 times the square root of 2 minus 24 times the square root of 2 equals negative 4 times the square root of 2. I hope this explanation helps you understand the process of adding and subtracting square roots with the same or different radicands. I'll see you in the next video.